Alright, so the last video in this unit is trapezoids. We're talking about trapezoids, and your learning target is I can use properties of trapezoids to solve problems. Okay, so let's get going on this. So first, let's go through some definitions, and first thing we're going to define is a trapezoid. Okay, a trapezoid is a quadrilateral, meaning it has four sides with exactly one pair of parallel sides. Okay, the other side cannot be parallel. If it is, that would be a parallelogram. A trapezoid only has one pair of parallel sides. These sides that are parallel are called the base sides of the trapezoid. That's really important that you understand that those are called the base sides of the trapezoid. The non-parallel sides are called the legs. Okay, the ones that are not parallel are going to be the legs. Now there's a special type of a trapezoid, and that trapezoid is the isosceles trapezoid. Isosceles trapezoid. If you need a spelling for it, it's right down here. Isosceles. And those trapezoids legs for an isosceles trapezoid are congruent. Okay, so let's go through some of the theorems. So first of all, we're going to go through just a basic trapezoid theorem. Okay, it's true with any trapezoid. Okay, and that is that consecutive interior angles are supplementary. Okay, what I mean by that, consecutive are the ones that lie right next to each other. Okay, now interior means that it has to be the ones on the inside of those transversals. Okay, this is actually just a transversal, really is all it is. And so if we look at it, that means 1 and 2 are going to be equal to 180. They're supplementary. 3 and 4 as well. Now, here's the thing. Do not be mistaken. 2 and 3 are not supplementary. 1 and 4 are not supplementary. It has to be the ones that create that transversal between the two parallel lines. Okay. Now, in terms of isosceles trapezoids, there's a couple theorems that are important about that. And the first one is that the base angles, remember the base sides are the ones that are the parallel sides. The base angles are congruent. So angle B and angle C are going to be congruent, and angle A and angle D are going to be congruent. They're not going to be congruent. A and B are not congruent. B and C are, A and D are. Okay, just the base angles that are formed from the same parallel line. And then the last thing about an isosceles trapezoid is that the diagonals are congruent. Okay, what that means then is that the distance between A and C is equal to or congruent to the distance between B and D. All right, let's do some examples. All right, example 1 wants us to find the measure of angle A. And the only thing that we're given here is that 1, this is a trapezoid because we have one pair of parallel sides. 2, that this is an isosceles trapezoid because those legs are congruent. And the third thing we know is that angle of C is 100 degrees. Okay? Now, here's what we do know about an isosceles triangle is that the base angles are congruent. That means angle C is congruent to angle D. And that also means that angle B is congruent to angle A. Okay? Now remember, if we know angle C is already 100 degrees, that means that angle D also has to be equal to 100 degrees. Okay? Now there's one extra thing. That's just the specific part about the isosceles triangle. Isosceles trapezoid. The only thing different now that we need to talk about is that for any trapezoid, that the consecutive interior angles are supplementary. That means they add up to be 180 degrees, right? So that means that angle B plus angle C is equal to 180. And it also means that angle A plus angle D is equal to 180 degrees. Okay, and let's use this last one here that we wrote down as a way to figure out what the measure of angle A is, right? Because we know that the measure of angle A plus the measure of angle D, which we already said is 100 degrees, is going to equal 180 degrees. And therefore, if we subtract 100 from both sides, we're going to find that the measure of angle A is just equal to 80 degrees. Okay, example 2 says that AD is 12x minus 11. That's this whole side. And BC, this length is 9x minus 2. We want to find the value of x so that ABCD, that trapezoid, is isosceles, which means that the diagonals are going to be congruent. Remember, that's one of the theorems from the front side, is that in an isosceles trapezoid, the diagonals are going to be congruent. So that means then that these two have to be the same, so we can set them equal to each other. We've got 12x minus 11 is equal to 9x minus 2. And then it's just algebra trying to solve for what x is. Subtract 9x from both sides, and we get 3x minus 11 is equal to negative 2. Add 11 to both sides. We'll get 3x is equal to 9. And finally divide by 3. And we end up seeing that x is equal to 3. Alright, so there's one last theorem I want to talk about in this video, and that's the trapezoid mid-segment theorem. Okay, and what that says is that the mid-segment of a trapezoid is, first of all, parallel to each base. That means that AD, XY, and BC are all going to be parallel. And its length, the length of that midpoint, or that mid-segment, XY, for this scenario here, is half the sum of the lengths of the bases. Okay, so that means that if you add AD and you add that to BC and you multiply that by 1/2, it'll give you what XY is, what that mid-segment is. Okay, so let's do an example about this. Example 3 says to find EF. That's this distance right here. And we know that EF is equal to 1/2 times the sum of the bases. So AD plus BC. That is our rule. Now all we have to do then, just knowing what the trapezoid mid-segment theorem says, is substitute these numbers into the equation in order to find out what EF is equal to. So we have 1/2 times AD, which is 13.5, plus BC, which is 8. And 1/2 times 13.5 plus 8 is just 21.5. And half of 21.5, if you were to multiply this using your friend here, we can do that. 1/2 times, what was it? 21.5 is 10.75. So the distance of EF is 10.75.